So, hello everyone, my name is Akshay and this is day 85 of our GFG POTD streak. तो मेरे को ये क्वेश्चन करने के लिए थोड़ा समय चाहिए था यार, इसलिए मैंने कल इसका वीडियो सोल्यूशन नहीं डाला था. तो आई वांटेड सम टाइम टू डू दिस क्वेश्चन एंड इसकी वीडियो में मैं क्या बोलूँ, लाइक फॉर ईच एंड एवरी स्टेप आई हैव टू मेक अ प्लान. तो ठीक है, वीडियो लेट है बट वी कैन स्टिल गो थ्रू दिस, राइट? तो शुरू करते हैं आज के स्ट्रीक को. तो इट्स मैक्सिमम नंबर ऑफ टॉयज. सो यू गिवन एन n टॉयज in a shop, and the cost of each toy is represented by an array. You are given Q queries. For the ith query, you have C amount, and you have n broken toys. You cannot purchase it. So the task is to find the maximum number of toys you can purchase using this C amount of money. ठीक है, तो ये क्या कहना चाहता है यार, मैं इसको तुरंत से पेंट पे ले चलता हूँ बिकॉज ये वीडियो बहुत लंबी होने वाली है. एंड इफ यू आर न्यू टू दिस चैनल, प्लीज सब्सक्राइब आवर चैनल एंड लेट्स स्टडी टुगेदर. ओके, so this is 8, right? So this is the toys and toys price mentioned here, and number of queries is 2, and this is given as 12, 2 and 3. तो पहली जो query उसे देखते हैं. So 12, 2, 2, 3, 4. So this is the amount of money I have. This is the number of toys that are broken, right? Hmm. That's the number of toys that are broken, and this is the index for the toys that are actually broken. So we have the toys as what, 8, 6, 9, 2, 5, and the indexing is one based indexing as of now mentioned in the question. So we cannot use the toys having the index 3 and 4, right? Having the index 3 and 4. Okay, so we cannot use the toy, this one, uh, this one and this one, we cannot use it, right? So the toys which we can use is 8, 6 and 5, right? And the money we have is 12. So I can, अब क्वेश्चन बदल चुका है कि यार you have this 3 toys and you have money. What is the maximum number of toys you can purchase? So if you want the maximum number of toys to purchase, then then what we can do, that we can buy the minimum. We buy the minimum cost toys first, right? तभी तो we can make sure that we have purchased the maximum number of toys. So we want to find the minimum number of toys first, right? So we will sort this array. So what it will be, 5, 6 and 8, and it is 12, right? As you can see, we can buy this 5 and the remaining amount will be having 12 minus 5, that is 7. Then we can buy this 6 and the remaining amount will be have 1. Now we cannot buy the third toy which is of cost 8 using this 1 money, right? So we will say that we can buy the maximum number of toys is 2, right? This is very simple, that after sorting you just have to run a for loop and we'll just मेंटेन आंसर वेरिएबल. तो ठीक है यार, तो ये तो इसकी हो गई फर्स्ट अप्रोच कि हमें जो भी डिफेक्टिव टॉयज हैं, नेग्लेक्ट दोज टॉयज फ्रॉम आवर एरे एंड जस्ट सॉर्ट द रिमेनिंग एरे एंड फाइंड द नंबर ऑफ टॉयज विच वी कैन बाय, राइट? सो दैट्स द थिंग. तो हम इसको कैसे कर सकते हैं? तो व्हाट वुड बी द स्टेप्स विल बी कि हमें इंडेक्सेस चाहिए होंगे, राइट? ये जो है, ये ये क्या इंडेक्स है? This is the actual index given by the question, right? But after we sort the array, let's say if we sort the array, it is 2, 5, 6, 8 and 9, right? When we sort the array, we need that previous indexes also, right? Because then we can just check in O of 1 using a hash set that if a particular toy is defected or not. Rather than for each and every query we make a new array, and we sort it again. So what I'm saying, that sort the array that is given in the question and save the indexes. So for 2 I can say the index was 4, 2 comma 4, and 5 I can say the index was 5. For 6 I can say the index was 2, and 8 I can say the index was 1, and for 9 the index is 3. Now I have the sorted array, I have the amount of money 12. I will just start the iteration from this point to this point, and before that I will put all the defective toys, all the broken toys in the hash set. That will give me privilege that while I'm iterating from this point A to point B, I can just check which are all the toys using this indexes, that hash set dot contains this index. That means we have the broken toy and I will not proceed to buy for that toy, right? As I can, so if I just write it for you, so the hash set will have the indexes as, let's say, 3 and 4, and I will start iterating from here. So I have money 12, right? So can I buy this toy of cost 2? I cannot, because the index of 2 is 4, and that 4 is present in a broken hash set, in the hash set named broken, which has the indexes of the broken toys. So I can say that I cannot buy this one. I just proceed to the next pointer, to the next element. And since 5, this index is 5 and it is not present in the hasher, that can be checked by O of 1 using the inbuilt function. So I can say now that I will buy this 5. I will buy this 5 and the remaining amount will be 12 minus 5, that is 7. Now I'll come to the third toy which has the index 2 and the price 6, the minimum price among these three toys. Right? That's why we have sorted. That's the main logic of sorting. So I can see that the index of this toy which is having value 6 is 2 but is not present in the hash set. That is, this is a product that which we can buy. So the remaining amount was 7, and if I buy this toy the remaining amount will be 7 minus 1, 7 minus 6, that is 1. Now I cannot buy this the further toy because that those toys values are greater than 1. This is 8. We cannot buy the value 8 with the value 1, right? So we will end the loop here and we will say that this is the, we will maintain a count. This will say that this is the number of toys. So what are we going to do? What should be our first step? First step will be to create a pair data structure so that we can store the what element as well as its indexes, right? And second step will be to sort it, right? Create an array list of pair and then sort according to the element and not the indexes. You'll use an inbuilt comparator there. The third loop will be, we'll just iterate for this thing, and in the meanwhile we'll maintain this hash set and all. So let's complete the first two steps and uh, we will look for the third one. So before coding this thing, let's discuss about its time complexity. So what I can see that first step is doing sorting, right? So I will use NlogN. Then for each and every query I'm doing some things, right? So for each and every query I'm making a hash set of k size, right? And then I'm iterating in the for loop. So I will write plus here. So this will be the overall time complexity if we code this solution. And if you just put the values that n is 10 power 5, then log of 10 power 5, then q. What's the constraint of q? Let's see it. So the q is 10 power 4. Okay. So it will be 10 power 4 into k. What's that? K. It is 10, so that's negligible. So but still, right, let's 10 and this is 10 power 5. You can see that this thing is making 10 power 4 into 10 power 5, that is 9. So clearly this thing is greater than 10 power 8. So if we are able to code this solution, that will give us TLE. But still, we will do this code and see how it works. So okay, so let's get to the coding part. Let's create a pair data structure. So I'm pausing the video to make a pair data structure. That is the thing that you do not need to see. It's already understandable. So I have made it, and now I need to make a list of element with its indexes, right? So let's make it. So I will make one array list of type pair, and I will say name it as array and new. And the second step will be to store the elements in this array list, and the second step will be to sort it according to elements. So let's store it. So I'll pause the video now to store the elements and sort it, and we'll resume. Okay, so I have stored the elements by using a for loop, and I'm making new pair for each and every I, and I'm pushing the first element and as well as its indexes. So let's just sort it now. So what I can say that collections, to sort an array list, we need to use collections.sort. It will be collections.sort, and I need to pass the name of the array list and how I need to do the sorting. So suppose in the array list we have these two entries A and B, which is actually a pair. A is a pair which is having the first thing as price and the second thing as index, right? So I need to what sort it according to the price. As you can see in the pair, I have made two things, price and indexes. So okay, so I can just write access it. Since it is a pair, then I can use the dot operator to access it. So I will write that a dot price minus b dot price. If it I have written the reverse, b dot price minus a dot price, then it would have sorted in the descending order, right? Okay, so that goes the selection. sorting part here. Now we just need a for loop to iterate in it, and we need to maintain a hash set for the broken toys. So let's iterate it. So, and okay, so let's iterate. So int I equals to 0 to I less than, how many queries are there? Q to I plus plus. Okay, so for each and every query we need to maintain a hash set, because each and every query has different number of defective toys. So let's make a hash set which is saying integer, and let's name it at broken hash set, right? Or you can just use the name set here. Fine. So let's just put all the broken toys here. So broken toys are mentioned where? It is mentioned from the third index, right? And the first the first index, that is the 0th index, and the first index saying that there are these many are the number of what? Broken toys. And from the index 2 it is starting the actual indexes of the toys which are broken. So I will just start our loop from 2, and I will go from j less than for each query size. So I will write queries. I will just come into one query, and I will mention dot size. So I just now was able to access each query list, and from j equals to j plus plus. Now what I have to do, I just need to add those indexes in a broken asset we just made. So broken dot add what? Queries of I, queries of I just accept the list, and I have to access now the jth index. So queries of I dot get j. But since this is a one based indexing, right, and we need to, and I am operating in this what um, 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 if you just see here, if I just made this thing, then what I'm doing, that I'm making this thing in a zero based indexing, right? So it is zero based indexing when I sorted the array using the pairs. So I will do the same thing where I will be taking the broken indexes. So I will do get of j minus 1. I hope this point is getting cleared why I'm doing the minus 1. Now the step is buy the toys greedily. And greedily means that buy the toys first which has the minimum value, right? That's the whole purpose of doing the sorting. So let's just now iterate. So for int j equals to 0 to what? J less than n. And hum, like, till when we are going to buy the toys? uh, we will buy the toys till our money didn't get to 0, right? So let's just store that money here. So I have the money of long money is equals to what? QUERIES. It was present at which index? It was present at get of 0, right? Okay, so I need to run the loop from in now what I'm doing, I'm running in sorted list, the above we just made at line number 86, right? So I will, and till when I have to run, my jth pointer should not go out of bound, as well as my money should not exhaust. So I will say that till money is greater than equals to array of get of our next indexes as it is coming. So array of get of j dot price, j plus plus, till the our money is greater than the next toy available to buy. So keep buying it, right? So I cannot buy the broken toy, so I will, that's the hash rate we made comes in play. So dot contains, this will, we do the all pre-processing above just to check this contains in o of 1. I hope you're getting this logic. Otherwise we just have to always have to what? Iterate for this thing. We always do a linear traversal to find a broken toy. So we made a smart move there. So if it's not broken, right? If it's not broken, and index. So what's the index? So array of get of j dot index. So this current index which we are operating at, if it's not present in the broken hash set, then use my money. So money will now be get deducted from array of get of j dot price, right? And I can say that number of toys bought is now increment. So just increment it. So toys BOUGST plus plus, right? So for buying the toys, let's make one more variable, that is int equals to, initially it was 0, right? Okay, so after this each and every query I need one array list, let's say answer, and I need to add the number of toys bought in each and every query. So I will say toys BOUGST, and at last I just will say return answer. And before returning the answer, I need to make an answer array list also, right? So I will say array list teacher answer. So seems fine to me. So let's compile and run and see. Okay, so there is one parenthesis error here, I guess. Okay, so let's compile and run again. Okay, so cannot find symbol. Okay, I have mentioned some spelling mistake there. Broken dot add q r I e. Check it again. So your output and expected output matches. So let's just hit the submit button, and it should not get submit because our time complexity, as we discussed, was NlogN plus q into k plus n. Okay, so it got submitted. So maybe they have updated the constraint in our this thing. What in the question? But since it's written that O of we used NlogN plus q of we made a hash set for k toys and then we iterate for n. So it is obviously going beyond 10 power 8. So it should have given TLE, but I guess they have made some updation in the question because I tried it and it was not getting submitted using this approach. So okay. So let's move to the second approach. So what should be a second approach? That we need to sort it, that is constant. We need to run the queries q times, that is also like the fact. We need to make a hash set, that is also we have to make it. How can we check within O of one time? But the thing that we are doing for n here, if we are able to optimize this n even below, how can that? So what I can see that why I was running this n, I was running this n in a sorted list, right? So whenever there is a sorted list, we can do the optimization by the binary search. So instead of using the linear traversal, I have to think of something that the same process, if it can be done using the binary search. So let's take an example. So let's take an example. So what was our array? So okay, so it was 2, 5, 6, 8, and 9. So I need to do and I have the amount of money 12. So I need something in login time. That is, if I do some binary search, then I need to know that in login how many toys I can buy in just one search. So I can see that for that thing I need to calculate the prefix sum. Why I am saying that? Let's calculate it and I'll explain it again. So prefix sum will be 2, 7 plus 6, 13, 13 plus 8 will be 21, and then 30. And the amount of money is 12. So if I apply the binary search on this array and get the lower bound, then where my pointer will be? Pointer will be pointing this here. Let's say answer variable, right? Now I got things that I can buy with the what? With the sum of 12 amount of money, I can buy only these two toys. I'm saying that using this binary search. But there is one catch. I'm not making sure that among these two toys, which are all the toys that were broken and I was not supposed to buy. I'm not taking care of those things, right? So for that, I need to do one thing. I need to traverse back after doing the binary search. I need to traverse back that which are all the indexes that were not supposed to buy and I've taken that thing in answer, right? So what I need, so how can I compare that? So suppose this index and which our answer is pointing. So suppose this index is, let's say, pointing to what? It is 0, 1, 2, 3, 4, 5. So it is index 1, right? So I need to check for the rest of the indexes, that is here. So if I am able to maintain a map of previous indexes with the new indexes, right? Then can we check it? Can we do that thing using a map? If I maintain the key value pair of previous indexes and the new indexes, can we do that? So let's do the binary search part first, and we will get to this part again, right? So let's go. So what is the thing that I need to remove from my code? I need to remove this thing. Where I was Q queries, right? So where I was running Q queries. So all these things inside here, I need to remove it, and I need to do what? Binary search, right? So let's do it. So I have written the code here. First, what I did for each and every query, I stored the answer. I made a new variable that the lower point and the higher point that goes to 0 and n, and I stored an answer that for doing a binary search, I will get a index, right, for the lower bound. So this answer is nothing but finding me the lower bound of the binary search for the amount we did. So okay, so this is the standard binary search code that while I let L is less than equals to h, we find the mid thing that L plus h by 2. And what I did here, that prefix of mid is less than equals to money. So let's say we were having a bunch of elements here. Let's say what thing? Let's say we are having 1, 2, 3, 4, and 5, and we have this sum amount at 10, right? So it will be 0 and it will be 1, 2, 3, 4. So 4 plus 0, uh, 1, 2, 3, 4, it will be 4, right? So 4 plus 0 by 2, that gives us 2, right? So this is 3. But I can see that the prefix of 3, what's the prefix of 3? Like I need to buy all these 3 toys. So the prefix of 3 it will be 1, it will be 3, it will be 6. So I can say that the prefix of 3 is 6, which is still less than equals to my money. So money is still greater. So if money is still greater, then I am saying that I can buy all 3 toys. So store the index here. So let's say we have this answer. I will store that index that pointing to mid, and what I will do, that there are still my money is greater, so there is a possibility that I can buy more toys. So what I will do, I will just update my pointer low is equals to mid plus 1, and I will search again in this point 4 to 5, that there is a possibility to buy more toys, but store that answer, this mid, that till yet I can buy for sure these 3 toys. And if not, I will update the pointer for equals to high is equals to mid minus 1, right? So I hope this is very clear to you. Okay, so I stored the answer and move ahead to see how much more can we buy. I have written the comments here also. Okay, so we did the binary search and we got the what? The index. So, okay. So where at we at this point in our dry run? We are at this point. If we consider this actual array elements which are given in the question, that 2, 5, 6, 8, 9, and for this thing 10, for the amount 12, I will say that my answer pointer AWS ANSW is pointing to this thing, right? Now what I can see, I need to store these, I need to make a hash set again to store all the broken toys. So let me just write here, I need to make a hash set again to store all the broken toys indexes. I need to do that, and I will compare the indexes of this thing with the indexes of this array, that is 0, 1, 2, 3, 4, 5. So if the index is there, like let's say for this 2, so if this damaged toy index, so what I can write here, if I just write it for you. So after making also a map, also a map of what previous index to new index, right? Okay, so what I'm saying, that I will make a hash map of new indexes with the current indexes. So the previous indexes were what? Let's traverse up, and where I made that list. So previous indexes were 4. Here you can see 4, 5, 2, 1, and 3. So let me write it here. Hmm. Okay. 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 So let's move ahead. Okay. Previous indexes. I was saying that it was 4, 5, 2, 2, 1, and 3. I'm taking from here 4, 5, 2, 1, and 3. It was previous indexes for the sorting thing. But, and what's the current index? Current index is 0. That is this one now. This is the current index. 0, 1, 2, 3, 4, right? And the element corresponding to it was 2, 5, 6, 8, and 9. I just wrote it. But in the map, I need this key value. This key value. So the first key is what? The indexes according to our this sorting list was done. Okay. The actual index where the elements were present in the given question, and this is the index. Just we if after we sorted it, so the elements were present for 2, 5, 6, 8, 9, and we have to do that for 0, 1, 2, 3, 4. Now the point is, the point was that we do the binary search and we had this answer index as this one. But I didn't consider the fact that there may be some of the elements that we should not have included in our answer because of that broken toys. And we can see that 2 was actually a broken toy given in our question, but we still have included it, right? So we need to move it from our answer. How can we do that? Let's say, this was 7, this was the uh, pointer 1, right? It is 1. So just what? Behind it, the pointer will be 0. So what I can say if this is what answer index. Let's say answer index minus 1. This is answer index minus 1, right? So if I say for the rest of this indexes before this thing, right? So for rest of the indexes, let's say I'm using IDX. So if the answer index is greater than these indexes, that means that I have considered all those. I have considered all all this group of index, all this group of index in my answer, right? And this group is nothing but this thing. This यहाँ पे बस zero ही element है, but if we consider this example of 0, 3, 5, 8 and amount is 10, then my pointer, it will be pointing to this point 5, 3, 8. This will point to this point, and I can see that this is the bunch of indexes I used in my answer, in my answer to get the number of toys, right? So ठीक है. So I just have to check that if this group of index which is actually having this 2 is actually this number 2 is actually present at 0, but it's actually has the broken index as 4. So I just have to see that if it's there, right? So what condition if I write? So I just have to iterate for the number of broken toys. तभी तो हम देख पाएंगे कि if that's the part of this group or not, right? So I have to iterate here, and I will, let's make a variable, let's say DTI, and that's stand for damaged toy index, right? And the first damaged toy was present at index 3 and index 4 according to the given question, right? So for the third index, I can see my actual, the new index is 4, right? So the new index is 4. So I just have to compare if damaged toy index which is updated to 4, if it's less than equals to my answer index minus 1, answer index minus 1, that is equals to 0, right? So it is not. And as you can see, the element here was 9, right? And we have not taken that 9 in the consideration. We can check otherwise also. So this will be not there. So now the pointer come to the second broken toy index, that was 4. So I can say the DTI for 4. So DTI of 4 is pointing to 0, the new index, right? That's why we made the map for. So it is pointing so it is pointing to 0, and which is less than equals to answer index minus 1. What is answer index? We did the binary search, and if we compute this index will be our depicting the number of toys we need to buy, right? So it is 0 less than 0, and as you can see, this fourth index was actually pointing to the element with value 2, and you can see that this is actually a broken toy, and we have included in this in our answer, so we need to remove it, right? So this equality holds true. We can use this equality to check. So when we know that we have included a broken toy, then what we have to do? First, we have to do answer minus minus, right? This answer is nothing but depicting the number of toys is bought. So we need to reduce the number of toys we bought, and the remaining money. So how we can find remaining money? So here is our answer, right? So I can say that the remaining money is what? The initial money minus prefix prefix of this index, that is what? Answer. It will say that previously it was 12 minus the prefix of this index, that is 7, that is 5. So we got the remaining as 5. And now what I can see, that in the remaining money I need to plus the amount for the toy that which we have not included, right? For the toy which we have not included as the broken one, तो हम यहाँ पे वो लिख देंगे यार. We will what, let's say array dot get off this DTI index, DTI dot price, right? We can do that. Or else, if this if these, if for the iteration we did for these broken indexes, if these all of them, or maybe let's say this for 3 was not taken in our answer, right? So we just need to, we maintain a broken hash set, right? So we just maintain to add in that hash set, that is D, E and I. Let's code this step and we'll discuss further. Okay, so what I do, I need to run a for loop for the number of broken toys, and the number of broken toys is 2. So j less than k, j plus plus. So I'm doing, running for loop for number of broken toys, because we need to check that if those toys have been considered in an answer or not. And before doing that, before this, before this, we need a hash map to check in O of 1, right? Need a hash map of what? Previous idx to new idx. So let's make a hash map. So let's go above where we do the sorting, where we did the sorting. And at that point, I will say that I need to make a hash map. Okay. So how I can write? So how I can write is, I will make a map of integer, comma integer, and I will say map is equals to new hash map, right? And I will run the for loop for our sorted list we have. So for int I is equals to 0 to I less than n I plus plus, and I will just add, so map dot put what, array dot get of I, the previous index, so it was pointing to idx, we can access that using the dot operator, and the new index, that is I, right? So that's it. So now let's come back here. So we did this thing, right? And now I actually need a hash set, right, to also maintain that whether this toy was broken or not. So how can we do that? How can we do that? Okay. So before running into the loop for the number of toys, so what is my remaining money? So if I say, so my remaining underscore m is what? The total money minus the prefix of answer. I already showed you in my pseudocode. Okay. And I will need one more variable, that is idx, which will pointing to answer minus 1. And this is actually from the 0 to answer minus 1 is the range. 0 to answer minus 1 is the range where we buy the toys. And in this particular range, we need to check if there is a broken toy lying or not. So for that, we created the hash map. So let's check it. We needed a for loop for the broken toy, and I will check it. So I just have to find first the index. So destroyed, or let's say damaged toy index is equals to map dot get of queries of I dot get of j plus 2, because it the first toy is starting from the second index, right? And we are iterating the loop from 0, so I have to do j plus 2 and the minus 1 for the 0 based indexing. So what I'm doing here is finding the new index, new index for old index. और old कहाँ पे था? वो sorting array का old index, ठीक है. So I just say that if d damage toy index, right, If it lies in the range from 0 to what, this answer, right, and the answer is pointing to idx. So if this particular destroyed toy index lies in the range of 0 to answer minus 1, so I can say that we have considered a toy which was actually stated broken in our question, and we need to reduce our number of toys. So I reduced it. And the second part, so I will have more money now, right? So if I have not considered a toy, I'll have to add that money to my current money. So the remaining money will be array plus equals to array dot get of this particular index, uh, eti, and उसका price निकाल के दो हमें for using the dot price operator. ठीक है. So what we did, see, we did that increase the remaining amount with price of broken toy. We just exclude from our answer. We just excluded from our answer. Else, if that not the case, that the broken toy index does not lie in the range of the answer we took, then just add it in the hash set. And why are we adding in the hash set? I will explain it to you. This is also a crucial part. I'll explain it. So DTI, right? So that is it, right? So now, why I added in this hash set? Why? Because come here. I have now, if you just took a very close look at this point, what is the remaining money I am having? What is the remaining money I am having? I was having 5, but then I excluded this toy of value 2. So what the remaining money I have is 5 plus 2 equals to 7. Yes or no? Right? So I have the what, this 7 money now, and I know that I can buy the toy which is actually having the value less than equals to 6. That present is here 6. We can buy this right now, right? So what I will do, I will run again a for loop from where to where. In this array, in this sorted array, that 2, 5, 6, 8, and 9, I know that my answer index is pointing to here, right? Or idx I use, right? So my index is pointing to us. So I will make a pointer, let's say s is equals to what? idx plus 1. I will go till this less than n, and I will see that if there are any other values which is less than my remaining amount, I can see 6 is there. So I will just add it. Also, I cannot blindly add it. I can add only if that is not broken, and that's the reason I made a set there. That's the reason I made the set there. So I will check if not broken in O of one time using this set, right? Then add it in my answer. Then add it in my answer, and finally I will say that now I have reached the answer, right? So let's code that part. So okay, okay. So let's make a hash set. We didn't make a set, right? So let's make a set integer broken. Mhm. New hash set. Hmm. Right. So we added in, since we are traversing for this broken toys, so we use that same for loop to add it in our broken.add dti. Right. Okay. Now what I'm doing, I'm using pick the rest required toys, right, from right, or let's say from answer plus 1 index to last, from already sorted array, right? We used it using the pair. So I will say int, now my new starting index will be idx plus 1. Idx was actually pointing to this, our answer, right? Okay, so I just have to traverse right, so I will just write, so for traverse till s less than n and n, the condition should be that remaining money should be greater than equals to r, the new what, the toy value we are encountering, right? So dot price. So if not broken, consider it an answer, right? So if not broken, add in what? Answer. Add in answer, right? We'll do answer plus plus. So how I can check? I can check if not broken dot contains the starting point index, then what I can do, I will just do answer plus plus, right? And remaining money will be decrementing now, because since we are considering that index of toy, s dot price, reduce the price by it. And at last, just you have to add, we made an answer array list, right? So I will add answer dot add answer, and answer is nothing but the number of toys we are actually buying for each query. So I think that's good enough. One more thing that we need to, for this second test case, I can see that the number of broken toys can be zero also, right? Or our answer can become zero. So when our answer can become zero, let's discuss that part also. So suppose in this question only, let's say for this array 25689, as in the question stated, suppose we have given the amount equals to zero, then we cannot buy any toy, and our answer will be pointing to equals to zero, right? Because using the binary search thing. So I need to mention one base case here. I will say that if answer is equals to zero, then I have to add answer in my list and just continue from there. So I will add answer dot add zero, and I you don't need to go further to execute the rest of the code. So I will say continue. Right. So I think I have handled each and every test cases. Hmm. ठीक है, so let's compile and run. Okay, so there is something logN. Hmm. Let's compile and run. Okay, so there are some errors. Let me rectify the. So there was semicolon missing in these two lines. So let's compile it again. Okay, so there's again semicolon missing somewhere in line number 152. Okay, let's compile it again. Okay, so cannot find the symbol of IDX. Okay, let's see to it. Okay, so while using the pair, I use the variable ind, right? So I have to use that ind here. Also, I made the prefix sum, but I didn't what? I actually did not made the prefix sum, right? So let's just made it also. So the last step, yeah. So this is for make that thing. We have to do something about it. What we should do? So yeah, it got submitted. I just submitted again, and it works. So it was working fine. I don't know. There was something, maybe a lag from the site. So okay. So it's getting submitted, and the time complexity of this thing is NlogN plus Q of the optimization, as we talked about, is log of n, right? And it's definitely getting less than 10 per 8. So So this code got submitted. So let me give you just a quick walkthrough of 1 to 2 minutes. So we made a pair, right? So why we made a pair? Because we want to buy the maximum number of toys. So we made a pair and sort that list of toys, maintaining the indexes so that we can take the minimum value toys first. And we sorted using the collections.sort and a comparator inbuilt. We made a Okay, so we ran. Then we what we did after we ran a queue length for loop for the series, and we stored the money, the k. We ran the binary search for the prefix sum because binary search was giving us the actual number of toys just by finding the lower bound of the amount in the sorted array. Right now, for that we were getting one thought that we just found the lower bound using the binary search, but there, we did not consider the possibility of considering all those toys which were broken. So for that range, so where was that range? We found that answer, it was 0 to answer minus 1, that is the index of the lower bound. So from 0 to index of lower bound we just found, we need to iterate for k broken toys which was mentioned in the question, right? And for that we maintained a map. We found the we mapped the old index with the new index that we used the new index we use for the binary search, right, for the binary search sorted array. And we just said that using the previous indexes, the new indexes of the array we use for the binary search, if that new index is in the range from 0 to lower bound of the answer we get using the binary search, then we need to reduce the number of toys, we need to reduce the remaining money, else we just need to add the in the hash chat, right? So now there may be a possibility again that we have this remaining money, and from the what the in the right hand side, like the lower bound we get from till the end point, we can again run a for loop and we can see that if we can further include some toys, because in the previous loop, in this previous loop we saw that there are some number of broken toys we considered, and then we deconsidered them using the previous and the new index of the hash map, and we increase the remaining amount. So if the remaining amount is increased, there may be a possibility that we can buy more toys in the right hand side direction from index plus 1 to the last element. And for that thing, this is the bunch of particular script, which is nothing but a while loop running from the lower bound to the last element. And if it's not contained as a broken toy, we include in our answer, and finally we add the answer and we return the array list of answer. So that is it here, that is the code walkthrough, and that's the summary. So the first complexity, it was nlogn plus 2q into k plus the linear traversal, but then we did the sorting plus q times k plus the logn, right? So that is it for today's streak. And आज का क्वेश्चन भी जो है वो भी हार्ड कैटेगरी का अगेन से फाइंड टू द सब स्ट्रिंग. So I will not make the video until and unless I'm very clear, so that I can make you guys a fully understandable the each and every topic about it. So the from the 2 to 3 days you can see that I'm uploading the videos late, but the whole motive of running this channel is that you get to understand all the approaches, right? All the approaches with the code. So we will maintain that streak and we'll maintain that understanding among us. So that's it for this video. We'll meet again in the days 85 GFG POTD streak of day 85. Till then, if you have not subscribed this channel, please subscribe it, and till then, keep studying, keep solving, and take care. Bye bye.